I am doing live for the audio of chapter 2 Is Matter Around Us Pure? Just give me a thumbs up so that I can be assured that my screen is visible to you. Yes, it is very much visible. So let's start with the chapter. So it is the second chapter of grade 9, Science, CBSE from NCRT. Is matter around us pure? How do we judge whether milk, ghee, butter, salt, spices, mineral water, or juice that we buy from the market are pure? Figure 2.1 is showing some consumable items. Have you ever noticed the word pure written on the packs of these consumables? For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of that substances are the same in their chemical nature. A pure substance consists of a single type of particle. In other words, a substance is a pure single form of matter. As we look around, we can see that most of the matter around us exists as mixtures of two or more pure components. For example, seawater, minerals, soil, etc. are all mixtures. 2.1. What is a mixture? Mixtures are constituted by more than one kind of pure form of matter. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a pure substance and cannot be separated by physical process into its chemical constituents. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is the same throughout. Soft drink and soil are not single pure substances. Whatever the source of a pure substance may be, it will always have the same characteristic properties. Therefore, we can say that a mixture contains more than one pure substance. 2.1.1 Types of mixtures. Depending upon the nature of the components that form a mixture, we can have different types of mixtures. Activity 2.1. Whenever you'll watch this video, kindly share it with as many friends of yours so that everybody can take the benefit. I have also recorded the audio of chapter 1. You can find it in the playlist. Let's start with the activity 2.1. Let us divide the class into groups A, B, C, and D. Group A takes a beaker containing 50 ml of water and one spatula full of copper sulfate powder. Group B takes 50 ml of water and two spatula full of copper sulfate powder in a beaker. Group C and D can take different amounts of copper sulfate and potassium permanganate or common salt, also known as sodium chloride, and mix the given components to form a mixture. Report the observations on the uniformity in color and texture. Groups A and B have obtained a mixture which has a uniform composition throughout. Such mixtures are called homogeneous mixtures or solutions. Some other examples of such mixtures are salt dissolved in water and, second, sugar dissolved in water. Let's move to the next page. Compare the color of the solutions of the two groups, though both the groups have obtained copper sulfate solution, but the intensity of color of the solutions is different. This shows that a homogeneous mixture can have a variable composition. Groups C and D have obtained mixtures which contain physically distinct parts and have non-uniform compositions. Such mixtures are called heterogeneous mixtures, mixtures of sodium chloride and iron fillings, salt and sulfur, and oil and water are examples of heterogeneous mixtures. Let's move to activity 2.2. Let us again divide the class into four groups A, B, C, and D. Distribute the following samples to each group. Few crystals of copper sulfate to group A, one spatula full of copper sulfate to group B, chalk powder or wheat flour to group C, few drops of milk or ink to group D. Each group should add the given sample in water and stir properly using a glass rod. Are the particles in the mixture visible? Direct a beam of light from a torch through the beaker containing the mixture and observe from the front. Was a part of the beam of light visible? Leave the mixtures undisturbed for a few minutes and set up the filtration apparatus in the meantime. Is the mixture stable or do the particles begin to settle after some time? Filter the mixture. Is there any residue on the filter paper? Discuss the results and form an opinion. Groups A and B have got a solution. Group C has got a suspension. Group D has got a colloidal solution. Figure 2.2 is showing filtration process. How is it done? Now we shall learn about solutions, suspensions and colloidal solutions in the following sections. So in-text questions are given, two of them. One is what is meant by a substance. Second is list the points of differences between homogeneous and heterogeneous mixtures. Let's move to the next topic, that is what is a solution. So it is a solution is a homogeneous mixture of two or more substances. You come across various types of solutions in your daily life. Lemonade, soda water, etc. are all examples of solutions. Usually, we think of a solution as a liquid that contains either a solid, liquid, or a gas dissolved in it. But we can also have solid solutions like alloys and gaseous solutions like air. In a solution, there is homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. More to know. Alloys are mixtures of two or more metals or metal and a non-metal and cannot be separated into their components by physical methods. But still, an alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. For example, brass is a mixture of approximately 30% zinc and 70% copper. Let's move ahead. So it is now a solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it, usually the component present in larger amount, is called the solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute. For example, a solution of sugar in water is a solid in liquid solution. In this solution, sugar is a solute and the water is a solvent. Second point, a solution of iodine in alcohol known as tincture of iodine has iodine solid as the solute and alcohol liquid as the solvent. Third, aerated drinks like soda water, etc., are gas in liquid solution. These contain carbon dioxide gas as solute and water liquid as solvent. Air is a mixture of gas and gas. Air is a homogeneous mixture of a number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. The other gases are present in very small quantities. Let's move ahead to properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer, 10 to the power minus 9 meter in diameter. So they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. Next topic, concentration of a solution. In activity 2.2, we observed that groups A and B obtain different shades of solution. So we understand that in a solution, the relative proportion of the solute and solvent can be varied. Depending upon the amount of solute present in a solution, it can, it can be called dilute, concentrated, or a saturated solution. Dilute and concentrated are comparative terms. In activity 2.2, the solution obtained by group A is dilute as compared to that obtained by group B. Let's move now to the activity, which is 2.3. Take approximately 50 ml of water each in two separate beakers. Add salt in one beaker and sugar or barium chloride in the second beaker with continuous stirring. When no more solute can be dissolved, heat the contents of the beaker to raise the temperature by about 5 degrees Celsius. Start adding the solute again. Is the amount of salt and sugar or barium chloride that can be dissolved in water at the given temperature the same? At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. What would happen if you were to take a saturated solution at a certain temperature and cool it slowly? We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. The concentration of a solution is the amount, mass or volume of solute present in a given amount, mass or volume of a solution. There are various ways of expressing the concentration of a solution, but here we will learn only three methods. The first one is mass by mass percentage of a solution, which is calculated as mass of solution divided by mass of solution multiplied by 100. Let's move on to the next part. Second is mass by volume percentage of a solution, which is calculated as mass of solute divided by volume of solution multiplied by 100. Third one is volume by volume percentage of a solution. Volume of solute divided by volume of solution into 100. Example 2.1. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. Solution given to the numerical is mass of the solute salt is equals to 40 gram. Mass of solvent water is equals to 320 gram. We know mass of the solution is equals to mass of the solute plus mass of the solvent. So it becomes 40 plus 320 grams is equals to 360 grams. Mass percentage of solution can be calculated as mass of solute divided by mass of solution into 100. So it becomes 40 divided by 360 into 100, which gives 11.1%. Next is 2.2.2. What is a suspension? Non-homogeneous systems like those obtained by Group C in Activity 2.2, in which solids are dispersed in liquids, are called suspensions. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Properties of a suspension. Suspension is a heterogeneous mixture. The particles of the suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. 2.2.3. What is a colloidal solution? The mixture obtained by Group D in Activity 2.2 is called a colloid or a colloidal solution. The particles of a colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particles as compared to that of the suspension, the mixture appears to be homogeneous, but actually a colloidal solution is a heterogeneous mixture, for example, milk. Because of the small size of the colloidal particles, we cannot see them with naked eyes, but these particles can easily scatter a beam of visible light as observed in activity 2.2. This scattering of a beam of light is called Tyndall effect after the name of the scientist who discovered this effect. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Figure 2.3a is showing you the solution of copper sulfate does not show Tyndall effect, whereas B, the mixture of water and milk, shows Tyndall effect. Next page. Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist contains tiny droplets of water which acts as particles of colloid dispersed in air. Figure 2.4, the Tyndall effect. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen with naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. The components of a colloidal solution are the disperse phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the disperse phase, and the components in which the dispersed phase is suspended is called as the dispersing medium. Colloids are classified according to the state, that could be solid, liquid, or gas, of the dispersing medium and the dispersed phase. A few common examples are given in table 2.1. From this table, you can see that they are very common everyday life. Questions. Differentiate between homogeneous and heterogeneous mixtures with examples. Question 2. How are salts, solution, and suspension different from each other? Question 3. To make saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. Find its concentration at this temperature. Table 2.1 showing common examples of colloids. So examples are fog, cloud, mist. It's a type of aerosol in which dispersed phase is liquid and dispersing medium is gas. Next example, smoke, automobile exhaust. It is an example of aerosol in which dispersed phase is solid, dispersing medium is gas. Next example, shaving cream. It's an example of foam in which dispersed phase is gas and dispersing medium is liquid. Next example, milk face cream. It's an example of emulsion. Excuse me. Dispersed phase is liquid and dispersing medium is liquid. Next example, milk of magnesia or mud. It's an example of salt. Dispersed phase is solid and dispersing medium is liquid. Next example, foam, rubber, sponge or pumice. It's an example of a foam in which dispersed phase is gas and dispersing medium is solid. Next example, jelly, cheese, butter. It's an example of gel in which dispersed phase is liquid and dispersing medium is solid. Next example, colored gemstone, milky glass. It's a type of solid salt. Dispersed phase is solid, dispersing medium is solid. Let's move ahead to physical and chemical changes. In the previous chapter, we have learned about a few physical properties of matter. The properties that can be observed and specified, like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc., are the physical properties. The interconversion of states is a physical change because these changes occur without a change in composition and no change in the chemical nature of the substance. Although ice, water, and water vapor all look different and display different physical properties, they are chemically the same. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in air whereas water extinguishes fire. It is this chemical property of oil that makes it different from water. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical change brings change in the chemical properties of matter and we get new substances. A chemical change is also called as a chemical reaction. During burning of a candle, both physical and chemical changes takes place. Can you distinguish these? So questions are given. Classify the following as chemical or physical change. Cutting of trees, melting of butter in a pan, rusting of almirah, boiling of water to form steam, passing of electric current through water and the water breaking down into hydrogen and oxygen gases, dissolving common salt in water, making a fruit salad with raw fruits and burning of paper and wood. Try segregating the things around you as pure substances or mixtures. 2.4 What are the types of pure substances? On the basis of their chemical composition, substances can be classified either as elements or compounds. 2.4.1 Elements. Robert Boyle was the first scientist to use the term element in 1661. Antoine Laurent Lavoisier, 1743 to 94, a French chemist, was the first to establish an experimentally useful definition of an element. He defined an element as a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements can be normally divided into metals, nonmetals, and metalloids. Metals usually show some or all of the following properties. They have a luster, shine. They have silvery, gray, or golden yellow color. They conduct heat and electricity. They are ductile, means can be drawn into wires. They are malleable, that means they can be hammered into thin sheets. They are sonorous, making a ringing sound when hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Non-metals usually show some or all of the following properties. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable. Examples of non-metals are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, chlorine, etc. Let's move to the next page now. Some elements have intermediate properties between those of metals and non-metals. They are called metalloids. Examples are boron, silicon, germanium, etc. More to know. The number of elements known at present are more than 100. 92 elements are naturally occurring and the rest are man-made. Majority of the elements are solid. 11 elements are in gaseous state at room temperature. Two elements are liquid at room temperature, mercury and bromine. Elements like gallium and cesium become liquid at a temperature slightly above room temperature, that is 303 Kelvin. Next part. So ultimately we have come to the compounds and we are just left with one more page and then the summary of the chapter will be left. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. What do we get when two or more elements are combined? Activity 2.4. Divide the class into two groups. Give 5 gram of iron fillings and 3 gram of sulfur powder in a china dish to both the groups. Group 1, mix and crush iron fillings and sulfur powder. Group 2, mix and crush iron fillings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. Groups 1 and 2, check for magnetism in the material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. Compare the texture and color of the material obtained by the groups. Add carbon disulfide to one part of the material obtained. Stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid and to the other part of the material obtained. Note: teacher supervision is necessary for this activity. Perform all the above steps with both the elements iron and sulfur separately. Now, few questions are given. Did the material obtained by the two groups look the same? Which group has obtained a material with magnetic properties? Can we separate the components of the material obtained? On adding dilute sulfuric acid or dilute hydrochloric acid, did both the groups obtain a gas? Did the gas in both the cases smell the same or different? Next. The gas obtained by group 1 is hydrogen. It is colorless, odorless, and combustible. It is not advised to do the combustion test for hydrogen in the class. The gas obtained by the group 2 is hydrogen sulfide. It is colorless gas with the smell of rotten eggs. You may have observed that the products obtained by both the groups showed different properties, though the starting material were the same. Group 1 has carried out the activity involving a physical change, whereas in case of Group 2, a chemical change or a chemical reaction has taken place. The material obtained by Group 1 is a mixture of two substances. The substances given are the elements iron and sulfur. The properties of the mixture are same as that of its constituents. Move to the next page, please. The table of difference is being given. I hope it is visible. So on left side, mixtures are given. On right side, compounds are given. The first point is elements or compounds just mixed together to form a mixture and no new compound is formed. Whereas in compounds, elements react to form new compounds. Point number two in mixtures, a mixture has a variable composition. Point number two in compounds, the composition of each new substance is always fixed. Point number three in mixtures, a mixture shows the property of the constituent substances. Point number three in compounds, the new substance has totally different properties. Point number four in mixtures, the constituents can be separated fairly easily by the physical methods. Point number four in compounds, the constituents can be separated only by chemical or electrochemical reactions. The material obtained by group 2 is a compound. On heating the two elements strongly, we get a compound which has totally different properties compared to that of the combining elements. The composition of a compound is the same throughout. We can also observe that the texture and the color of the compound are the same throughout. Thus, we can summarize the physical and chemical nature of matter in the following graphical organizer. So matter could be solid, liquid, or gas. It is of two types, pure substance mixtures. Pure substances are divided into elements and compounds. Elements show these two characteristic features. One is cannot be broken down to simpler substances. For example, copper, oxygen, iron, hydrogen, mercury, etc. Whereas compounds have fixed composition, can be broken down into elements by chemical or electrochemical reactions. Examples are water, methane, sugar, salt, etc. Homogeneous mixtures are those which have uniform composition. For example, sugar in water, salt in water, sulfur in carbon disulfide, water in alcohol, etc. Whereas heterogeneous mixtures, they have non-uniform composition. For example, sand and salt, sugar and salt, water in oil, etc. So with this, we end up with the chapter 2 of grade 9 science NCERT, and the summary of the chapter is what you have learned. A mixture contains more than one substance, element and or compound mixed in any proportion. Mixtures can be separated into pure substances using appropriate separation techniques. A solution is a homogeneous mixture of two or more substances. The major component of a solution is called the solvent and the minor the solute. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution. Materials that are insoluble in a solvent and that have particles that are visible to the naked eye forms a suspension. A suspension is a heterogeneous mixture. Colloids are heterogeneous mixture in which the particle size is too small to be seen with the naked eye but is big enough to scatter light. Colloids are useful in industry and daily life. The particles are called the dispersed phase and the medium in which they are distributed is called the dispersion medium. Pure substances can be elements or compounds. An element is a pure form of matter that cannot be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements chemically combined in a fixed proportion. Properties of a compound are different from its constituent elements, whereas a mixture shows the properties of its constituent elements or compounds. With this, we are coming to an end of grade 9 science. Chapter 2 is matter around us pure. Consider subscribing. We'll be back with chapter 3 soon. Thank you.